Alright, so this video is talking about systems of linear inequalities, and all systems are is it just means many. So on a single graph, there's going to be more than one linear inequality graphed on it. So here's a rubric. Your level 1 is if you need more help becoming consistent. Your level 2, which is your passing grade, is if you can graph the solution of one linear inequality, if you can determine the solution of a linear inequality, and if you can determine a point is in the solution of a linear inequality and match the graph to the equation. Or sorry, I should say the linear inequality, not the equation. A level 3 is when you can write a system of linear inequalities for a given graph. So this is what we're doing today. If you can graph the solution of a system of linear inequalities and determine if a point is in the solution of both or more, if you can determine if the boundaries and their points of intersection are in the region, and matching situations and the graphs to set of linear inequalities. And then your level 4 is your word problem. So today we'll be working on the level 3 questions. All right, so another goal for today is learning how to graph the following and exploring those systems. So before we move on, I'm going to actually break down this funky looking equation, and we're just going to talk about what all those symbols mean. So first we have the fancy brackets. Now what this is talking about is that we're in the domain with x and y. So we're dealing with x and y as our variables. So if we were to read this left to right, this would say x and y. This line means such that. And then here is our linear inequality. X minus 2 is greater than 0. And then this last part. This means that x, this fancy looking E, means belongs to. And this is talking about what kind of number system. So in this example, we're talking about the real numbers. And then lastly, it's also saying that y belongs to the real numbers. There we go. So this here, switch over my color, is that linear inequality that we will graph, and the other information is just posted. Nope. All right, so we're just going to review types of numbers. Natural numbers are whole numbers 1 and greater. So there's no negatives, no decimals, no fractions. Whole numbers are like natural numbers, it's just we include 0. So it starts at 0 and goes up. There's no negatives, no decimals, no fractions. Integers includes positives and negatives, but no decimals or fractions. And the real numbers are all numbers you can place on a number line. So any number you can place on a number line. These are all the numbers you have learned so far. So it includes rational and irrational. So any number that you can think of. How to graph different number sets. So you'll want to write this in your notes. So real numbers, that's how it would be written. X belongs to real numbers, Y belongs to the real numbers. So R represents real numbers. If I jump down to integers, they use an I. And for whole numbers, they would use a W. And if we were ever dealing with natural numbers, they would use an N. There we go. So for real numbers, they're any number that we can think of. So we're going to shade the half plane. So wherever that solution lies, we're going to shade it. And then if our inequality does not include we're going to dash the line, but if there is a less than or equal to or greater than or equal to, we're going to draw the solid line. So this is important to remember. Integers, because there's no fractions or decimals, the numbers can be positive or negative. We have to stipple the half-plane solution, so we have to draw those dots. And the reason why is because our answers are only lying on those intersections where all those whole numbers are, not in the middle. And whole numbers, there's no fractions or decimals allowed. The numbers must be 0 or higher and no negative. So we stipple or dot that half-plane solution, but only will work in that quadrant 1. So if here was an example, we would dot only in that quadrant because we can only have positive numbers. All right, so we're going to begin our first example, graph the solution set for each linear inequality on our Cartesian plane. All right, so we have x and y such that this is the only thing I'm really going to worry about because that's what I'm going to graph. And I don't really like how it's written, so I'm going to, and there's no y, so I'm just going to move it so that that -2 is on the other side. So I'll add 2 to both sides, and I get that x is greater than 2. So on my x number line, I'm going to plot where x is 2. Now, this means that my answer is x is greater than 2. It doesn't include 2, so I need to draw my dashed line. I'm dealing with real numbers, so I get to shade. And I got to figure out where my answers lie. So if I want to test the point 0 and 0, 0 is not greater than 2. So I'm on the other side, and I get to color it in. And then I'm done. So here's the next one. It's not in y equals mx plus b form. In fact, there is no y, or sorry, there's no x variable. So I'm just going to move this 6 over, and I'm going to get y by itself. All right, so I'm going to divide by -3, and remember that rule, if we ever divide or multiply by a negative, we have to flip that sign. So now we get y is less than 4. So I'm going to plot 4 on my y number line. 4 is included in my answer, so I'm going to draw a nice solid line. Now I'm dealing with the integer, so that's dotted, because I can have positive and negative whole numbers. And I got to figure out where my answers lie. So if I test the point 0 and 0, I get 0 is less than 4, which is true. So you're going to just place a whole bunch of dots to show that our answers are on this side of the line. And they're integers. So I'm just putting them right on those crosses. Good enough. No. Okay, here's another one with w means whole numbers. So here's my equation, and they nicely put it in y equals mx plus b format for me. So I'm going to plot my y-intercept, and then my slope is 2. They didn't write a fraction, but I can put it over 1. So I go up 2 over 1, up 2 over 1, and this is a solid line because of that linear inequality. So there's my solid line. Figure out where my answers are. So I'm going to use that point 0 and 0. I can use any point I want. I just use 0 and 0 because it's the easiest and it's not on that line. 0 is less than 1, so that's true. I'm using whole numbers, so that means I'm only in this first quadrant, and I am on this side of the line. So I'm only dotting this quadrant here. There we go. All right, so here are the following practice questions. Just pick any four. Okay. Word problems. Actually, we'll stop the video here and then I'll make another one for word problems.